Hello, we will be presenting our proposed paper, GOTLoc, based on the delivery scenario. We hope this presentation helps you better understand GOTLoc. Suppose someone wants to have a pizza delivered by a robot. The person needs to direct the robot by explaining the location using the arrangement of objects and their relationships. The robot then identifies the location by utilizing the text description and geographic information stored in the database. We present GOTLoc as a solution to the text-based localization challenge. Here is the architecture of GOTLoc, and we will now explain the process within the framework of the target scenario. This is the target scene that the person wants the robot to locate. To communicate the scene to the robot, it is essential to break it down into objects and their spatial relationships. Identifying objects and their spatial relationships requires organizing the space based on segmentation. Using the arranged objects and their relationships, a text description can be generated using a sentence template. The object 1 is on the relationship of the object 2. At the same time, on the other side, the delivery robot relies on geographic data, such as OSM, to determine the destination's location. OSM provides nearby geographic information, such as nodes, ways, and relations, for a single GPS point. To enhance understanding, we divided the loaded OSM data into segments. GOTLoc creates scene graphs from the text description and OSM to facilitate the comparison of multimodal data. First, GOTLoc creates a text scene graph using the provided text description. The text scene graph is constructed using the objects and spatial relationships extracted from the text description. Second, the loaded OSM data is transformed into a map scene graph. The OSM scene graph is created using the objects and spatial relationships derived from the OSM data. Typically, the resulting OSM scene graph contains more nodes and edges compared to the text scene graph. Using the scene graphs, GOTLoc identifies the best matching pair. To streamline the retrieval process, GOTLoc incorporates a candidate extraction step, where candidates are identified using the vectored. Using the extracted candidates, GOTLoc computes similarity scores for each pair, and identifies the best match by selecting the pair with the highest score. The scene retrieval network utilizes graph transformers to produce joint embeddings of multimodal scene graphs. Through the scene retrieval and selection process, GOTLoc identifies the most similar scene, where the text scene graph serves as a subgraph of the OSM scene graph. Finally, the robot can locate the correct position and deliver the pizza. Thank you.